Hi, this is worked example 13 from exercise 7.05 on page 261. I haven't typed it up because it's quite long and it takes me a long time to tap away at my tablet. But Charlotte has a loan of $15,000 at 9% reducing interest. The interest is compounded monthly and her repayments are $153 a month. So the way to do this is using a table, but we need some values before we can head off to our table. So we know that we're going to use basically a recurring sequence. So we're going to use n plus 1 equals r a to the n. And for that we know for r, we know r is equal to 1 plus I. So we need the I. The interest rate is equal to 9% divided by 100 multiplied by its compounding period, which is monthly. So our interest is equal to 0.0075. The actual formula that will end up for, so maybe it is easier if I trip to the other one. So let me just show you the table that we'll use. If I go here and go here and then go search. Alright, so this is the table that we'll be using. So it's for the first 6 months. So we need 1, 2, 3, 4, 5, 6 months. We start off with the original principle, and here it is, we're going to use that Rn to the Ra to the n. So we take our 15,000 and we multiply it by 1 plus the I, and we get the new value here. Now, the interest earned on that is just the $112.50. So just the $112.50 goes in here. She pays then $153. So we take the new principal and subtract the repayment, and we get this value here, $14,959.50, and we bring it, without ruining the sheet, but we bring it down to here. So bring it down to here. Then that becomes the principal for the second month. So we note here, we don't actually have to do anything with this interest. In the book, they've put this column in. It might be that if you wanted to say what was the total interest in the whole loan, that might be useful to have that column. It's not essential. Okay, but you do need to have this column, you need to find this column, you need to know this column, and you need to put in this column. All right, so we had 14,959. So at the beginning of the second month, she owes 14,959. So that's our new principal for the second month, and we multiply it by the R, and we get 15,071. So out of that, $112.50 is the interest. Now they're the same, but as you look through the example on page 261, you'll see that that changes up each time. So here we go. We've got $15,071.70. She pays $153. So at the end of month 2, she's actually owing $14,918.70. So that then becomes your new principal. And off you go again. So this one will be $14,918.70 times the 1.0075. You see why it was much neater if I type. And we subtract the 153, and then this value back here is actually equal to $15,030. Going down a little bit each month. This is always a good calculation if you want to borrow money for a car to see how slowly things reduce when you borrow money, and how much interest you pay, how much extra, rather than just saving up. Okay, so this ends up being 150 0.59 minus the 153, and then that new balance becomes $14,877.59, and then off you go. So that then $14,877 comes in over here, and off we tootle again and repeatedly do that equation until the table is full.